So with this inequality, we're just solving for x, and we can treat this just like an equation for the most part. There's just a little bit we need to remember. Okay, so I'm going to go ahead and copy it down. X plus 2 is greater than 7 times x minus 5. So when I treat this like an equation, that means I'm going to start by doing the distributive property on both sides. So I can distribute the 6, I can distribute the 7, and when I do that, I get 6x plus 12 is greater than 7x minus 35. And still treating it like an equation, what I want to do is I want to move all of the number terms to one side, all the variables to the other. So I'm going to add 35 to both sides. And these cancel out. I'm left with 6x plus 47 is greater than 7x. So now I want to move my variable terms over to the other side. So I'll combine those on the right. I'm going to subtract the 6x from the left. And this happens to work out very nicely to where 47 is greater than x. Another way of writing that is just flipping it to say x is less than 47. And so that's going to look like our answer here for E. So the thing about inequalities, the thing to remember is that the inequality direction never flips unless you're multiplying or dividing by a negative number. So if you ever multiply or divide by a negative, that would change. So in this case, if this happened to be a negative x right here, I know that wasn't the case, then I'd have to divide by -1 on both sides. That would cancel out. And then this would turn to -47, and the inequality would actually change directions. All right, so that wasn't our particular problem, but I just wanted to give you an example. And I'm not going to go through and give you a bunch of practice with this, but I wanted to jog your memory at the very least. All right, so what we're going to do with this today is kind of combine a bunch of stuff we've been learning into one. We call it solving right triangles. And the main idea behind this is rather than me giving you a triangle diagram and say, solve for this side or solve for this angle, we're going to say instead, solve for everything that we don't know. Because if you have 3 pieces of information in a right triangle, one of them being the 90-degree angle, if you have 3 pieces of information, you can solve for the other 3. There's 3 side lengths, there's 3 angle measures. If you know at least one side and the 90-degree angle and then one other piece of information, you can solve for everything else. If all they give you are angles, that's actually not enough, but no worries. That's never going to be the case. So let's look at this. It's a little bit hard to see, but this is a 6 right here. So let me just make sure you know that. And what we're going to do is we're going to solve for all of the missing information. So what's the missing information? I know the side length BC is 6, the angle A is 50, and angle C is 90. So I'm going to solve for angle B. I'm going to solve for the hypotenuse, side length AB, and I want to solve for this missing length right here, AC. I can solve for all 3 of those. And I can solve for all 3 of those in any order. You don't have to do this in a particular way. And what we're going to find is that there are actually multiple ways of solving for missing side lengths, missing angles, and you have a lot of options, especially when you're getting to the end. But hopefully right now, what I want you to do is stop and think, like, if I was given any one of these things to solve for, how could I solve for it? Yeah. Okay, and I bet some of you at home didn't hear that. That's perfect. So we can solve for angle B right away. We do not need to know any of the side lengths because, like Caden mentioned, though you didn't probably hear, we know that angles in a triangle have to add up to 180. So if we know 2 of the 3 angles, we can solve for the 3rd. So just to make that more formal, I'm going to add some things here real quick. I'm going to give these some terms. I'm going to call this one X, this one Y, and this angle Z. All right. So I can, as far as what we just talked about, the measure of angle Z plus 50 plus 90, don't forget that this symbol right here in the corner is an actual piece of information for us. That means 90 degrees, and you have to remember that when it comes to writing equations. Those 3 have to add up to 180. So now we can go through and anyone can figure out that and put the answer down on the screen. And there we have it, 40 degrees. Now we don't have to use that angle the rest of the time, but let's say if we're solving for, I'll go ahead and write it down here, but that was correct. If we are solving the right triangle, meaning we want to find all of the missing information, then that's one thing we could do. I mean, that's one thing we could do is to start off with that. If we don't start with it, we can do that calculation later. Like I said, we don't have to do this in any particular order. So now I'll just open it up to you guys. And which one do you want to solve for next? X or Y? Go ahead. X. Let's solve for X. And I will say this, just to be on the safe side, just in case you made a mistake, and I'll tell you you didn't make a mistake, like this is 40 degrees, but sometimes you get weird decimals for your degrees. Just to make sure there's no mistakes, let's go with the angle that they give us as our reference angle. So maybe I'll do this in yellow as a reference angle. So it's always good to go with the known information as your baseline, but you can use information you calculated for yourself. All right, so if that's 50 degrees, then we need to label our sides. And I'll let you guys go ahead and put on the screen where adjacent, opposite, and hypotenuse are. Okay. So yeah, we get one person to write on the screen, but I hope every one of you is able to say, this is how it should be labeled, and you can go ahead and do that on your own, in your head at least. And I also encourage you to write this stuff down. And I've mentioned this before, but if you want to have a problem on your reference sheet, and those of you at home, you have anything you want to use, and those of you here can use whatever also, but you have the physical copy. If you want to put down some practice problems on that, just have a quick reference for, so you can remember this is how we do inverse trigonometry. This is how we do regular trigonometry. And now we're going to be looking at some other things, like we used triangle sum theorem. That came back into play. So now that we've got this labeled, I'm going to go ahead and, well, if we're solving for X, which trig ratio makes sense to use? Yeah, go ahead. Tangent. All right, notice we're using the opposite and the adjacent. We don't care, in this problem, we don't care about the hypotenuse. All right, and I'm gonna get rid of that X because we will use the hypotenuse later because we still need to solve for it. All right, so at this point, just like was mentioned, oops. We've got tangent of X equals the opposite over adjacent. So I'm going to run through this part pretty quickly because we shouldn't need to take the time to set up and solve this part of the equation. You should be pretty familiar with this by now. So I put the opposite over the adjacent. And now you can go through and you can solve for X. I will pause the video here and you guys can go through and solve for X on your own. I'll just put X equals right here and someone can fill in what they get as an answer. So we got 5.0 for this. Does everyone agree with that number? Okay. Does anyone need to see the full process of going through and solving for X? You can give a thumbs up if you want to see it. Okay, I'm not seeing any thumbs up. The assumption is that you guys know what you're doing with this part of it because we practiced with it for about a week now. So if you're still struggling with it, you can stick around after everyone else signs off and we can go through some more practice with it. All right. Yeah. There are two ways this could be set up. So if your X ends up being on the bottom, then you're going to end up using division with your final calculation. If your X is in the numerator, so if this was flipped, then you would actually end up multiplying. But and the main thing, so maybe it's just worth talking about it a little bit. Just remember, you're always multiplying by whatever's in the denominator. So if the X is in the denominator, you multiply by X. If the 6 is in the denominator, you multiply by 6. You want to get rid of the bottom of the fraction. Okay. I'll call that good. So now we want to solve for Y. And we have so many different options for how we can solve for Y at this point. All right, so let me just show you a couple different ways. And maybe what I can do is I'll keep using the same reference angle. And at this point, I don't need to worry about the adjacent because I've already discovered that this is 5.0. So let me show you some of the ways we can solve for this. I could solve for it with, let me do the math here. It could be the cosine of 50 degrees equals 5.0 over y. It could be the sine of 50 degrees equals 6 over y. If that isn't making sense, let me know. I could even do this. I could say the cosine of 40 degrees. Now that's an angle we calculated, but we can use it. Cosine of 40 equals 6 over y, or the sine of 40 degrees equals 5.0 over y. The 0.0 technically doesn't matter here, but just to show that we calculated that. So those are 4 different equations. And let me show you one other way we could solve for this. So we have a right triangle. And if I draw this triangle separately over here without all the other things, I've essentially got 5, 6, and x. And that's a right triangle. So do we have a way of solving for a missing side when you know 2 sides of a right triangle? Right. What do we call it? You remember? Pythagorean theorem. This is an option that we have. I'm not saying this is the best way of doing it. So here, I'm just going to number these. We have 1, 2, 3, 4 different equations, which all equal the same thing. And then here's a 5th. I've got a squared, I'll call it 5 squared plus 6 squared equals my hypotenuse, which is unknown, y squared. And all of these will equal the same thing. So I encourage you to just pick one of those. Pick one of them, go through and solve, and let's make sure that all these come up with the same value. All right? Thank you. All right, so you can see that there are slightly different answers based on which equation you pick. But when we round this to the nearest 10th, they're all 7.8. Notice that all of them are going to round to 7.8. All right. And the difference between them, the biggest value is 7.83. The smallest one is 7.78. That's just 5/100ths difference. And that's entirely due to the fact that we rounded this value up here. This wasn't exactly 5.0. If we had used the exact value, we would have gotten it 100% the same. All right, but because we rounded, it's not going to be exactly the same. All right, so with that, you can see how this all works. Now, it seems like I gave you a lot of options, maybe to the point where it seems overwhelming. You don't have to solve this 5 different ways. You only need to solve it one way that makes sense to you. All right, so when you looked at this, if you were solving for the hypotenuse right here, and you saw one way that worked, just do it, solve it, and you're good. I just wanted to show you have a lot of options. Okay, so let's do one more practice. And that's going to be right here. We've got 2 sides given. And as far as what we still need to solve for, we know the 90-degree angle. That is a piece of information that's given to us. So we have, we'll call that angle A. This will be angle B. And I'll just call this X. All right. So what do you want to solve for, guys? A. All right. So if A is what we're solving for, then A is the reference angle. So I want you guys to go ahead, add labels for hypotenuse, opposite, and adjacent. All right, so now we've got adjacent, opposite, and hypotenuse. That is an A right here, not a 9. So that is our adjacent. maybe I should have picked different letter sets, A, B, and X, because, well, that can be confusing when it comes to adjacent. But anyways, we've got it. So now we need to set up a trig equation to solve for a missing angle. And which trig equation seems to make sense? All right, I'm hearing cosine. Anyone have thoughts about that? First of all, do we have thoughts on the labeling? All right, this is something I didn't mention a second ago. I wasn't looking very closely, but yeah, this is actually a tricky right triangle. This is a common thing where we always need to make sure that our hypotenuse is opposite the hypotenuse. So actually these two right here should be flipped. So I'm going to relabel this one as the adjacent and this one as the hypotenuse. So make sure your hypotenuse is opposite the right angle. But besides that, luckily we still get to use cosine. And you would have noticed something if you didn't ever catch that mistake. You would notice a mistake in a second. Like you would end up, if we hadn't relabeled it, it would look like this. Cosine of A is going to equal, this is with the way it was labeled before, 21 over 14. If you try and do the inverse cosine of 21 over 14, you're going to get an error on your calculator. So you'd get some kind of a warning that you did something wrong. Well, anyways, it's not 21 over 14, it's 14 over 21. So now this is, of course, I just said it a second ago, and this is where we can go through and do it. This is going to be what we learned before, inverse cosine. So if you're given, we'll round this to the nearest tenth. Luckily, your calculator handles all of the complicated math here. All right, and I'm seeing 48.2. What do you guys think about that? Seeing some agreements. Thumbs up if you agree with that. Good. Thumbs up at home. Actually, those are all people here. There we go. Some thumbs up at home. So 48.2. And keep in mind, like I mentioned before, we don't have to start with solving for A. We could have solved for anything first, but now we know this is 48.2 degrees. All right, so you might see it your own way, but as a class, what should we solve for next? B or X?
B.
B. All right. Again, you don't have to solve for that one next, but let's do it. What are you thinking as far as how we should solve for B? What are you thinking? All right. Triangle sum theorem. This is a pretty simple calculation, so maybe this is going to be your preference when you're solving. If you know two angles and you're solving for the third, this would be a good way of doing it. So at this point, we do have 90 degrees plus 48.2 degrees plus measure of angle B equals 180. And you guys can fill that in. So there we go. We just solved pretty straightforward. That second calculation is 41.8. Now, the only danger with doing this, and it's not that big of a deal. I'm not trying to dissuade you from solving it this way. The only thing is that if we got this angle wrong the first time, then we're going to get the second angle wrong. But when I'm grading the tests, if I notice that you got the first one wrong, but these two add up to 90 degrees, then I'll try and catch that. I can't promise I will. I'll try and catch that and give you credit for the second one. But in general, if you get the one angle wrong, you're going to get the other one wrong. Okay, so now let's figure out how we should solve for X. Or is that it? Or were you going to mention something? I'm sorry. Okay, so what were you thinking for X?
set it up as sin 41.8 equals x over 21.
So which angle, so if we do set it up as sine, and remember there are 5 different ways we could solve for this. All right, so if you see it differently, by all means, go a different route. But if we set it up this way, which angle should we be using sine with? Is it the 48.2 or the 41.8?
48.2.
It would be the 48.2. And the reason is, notice, I'll go back to blue for this. When my reference angle is 48.2, this is the opposite. The unknown x is the opposite, and the hypotenuse is the hypotenuse. So sine uses opposite and hypotenuse. So I want to make sure that one of the two angles, or one of the two sides lengths that I'm using is the unknown. So if I use 41.8, notice 14 would become the opposite, and I already know that one. So I don't need to use sine. Okay, so sine of 48.2, and you can finish it out. Tell me what the rest of the ratio would look like.
X over 14.
X over, not 14 here,
21.
21, yeah. So it's over the hypotenuse. We could set it up a different way. If I did x over 14, which trig ratio would that be?
Tangent.
Of
48.2.
48.2. Of course, we have other ways we could set it up with 41.8. So let me give you this. If this was x over 21, which trig ratio would I be using with 41.8?
Cosine.
That would be cosine. Remember, in this case, my opposite and adjacent would flip. So this would be the adjacent, this would be the opposite. So cosine of 41.8, and if we set it up one last way, what would the last equation look like? There you go, tangent. What would the two ratios be? Or the two numbers in the ratio be?
14,
Well, it would be 14 over the adjacent side. What's the adjacent side? X. There it is. And again, if you want to avoid doing trig as much as you can always do this with Pythagorean theorem. So x squared plus 14 squared equals 21 squared. Now, if you solve this 5 different ways, you will get, again, just slight differences in the answers. No more than like 500th difference between them. But they'll all round to the same number in the end, the same tenths. Okay. Was that? Yeah, and actually, we don't need to sit here and solve that. You should know how to go through and do the solving for x at this point. So I just wanted to talk about kind of all the options available. Hopefully you guys are feeling very aware of what you can do when you're solving for right triangles. So there will be problems on your test where I ask you to solve for every missing value. So just make sure you have, you know what your options are and what's in your toolbox for that. Okay, are there any questions on this? Okay, then let me just quickly show you what your homework is going to look like. All right, your homework is another PDF, and this is just a really good review of everything we've talked about. It starts at the beginning with, here's just a triangle. It asks for the sine of C. You need to figure out what your opposite, adjacent, and hypotenuse and figure out your ratios. Now, you don't have to do all these problems. In the homework, it tells you which specific ones you need to do. There's about 9 or 10 that you have to do. Though I will say, I highly encourage you to do all of these problems until you feel like you've mastered it. where you could approach any problem and you know exactly what to do. Keep practicing, but there are specific ones you'll turn in. This is that really straightforward stuff where all you have to do is plug it in. And if any of these are confusing for you, let me know. And if you're at home and you're logging off and you're working on it and you don't get it, then what I'd recommend is put a star next to the ones that you're struggling with, and you can bring it to class tomorrow. We'll hang out and you can get some help with any of these problems that you're struggling with. Okay, with these, I did change the instructions in your homework very slightly. Instead of just solving for x, I want you to solve the triangle, and that means solve for all missing sides. You're not just going to solve for x here, you're also going to solve for y. I'm not writing yet. You're going to solve for y, and you're going to solve for z, okay? So I want you to solve for all the missing sides, all the missing angles, everything that's not there. Okay. So you're going to have a couple of problems here, a couple of problems here where they give you two sides, and I want you to solve for all the missing pieces of information. And then there are some word problems at the end. Okay, that's pretty much it. I'll also tell you this. There is an answer key at the bottom. I intentionally left it in because I want you guys to be able to check your work along the way. So use that answer key. Don't just copy the answers and turn it in. I want you to actually do the work, make sure you understand it. And having said all that, I believe that's all I need to say today. If you have any questions on anything, certainly feel free to stick around. If you are good to go, you can get started on your work. And I will see you tomorrow. Last thing to say, I apologize. The test was supposed to be tomorrow. Tomorrow's going to be your practice test. Wednesday will be your test. So you just gained yourself a day. Okay. And with that, have a wonderful day. I will see you tomorrow.